So again, as I mentioned, as we just saw, you can find these lecture notes up there on Canvas if you like to use them. We're gonna go through chapter 1. We may not talk about everything within chapter 1, uh, and that's because a lot of chapter 1 is sort of like an introduction or a review. There's some good math review and stuff like that in chapter 1. So again, if that's helpful for you or you need some review of math, uh, we'll go over some of it here, but you may want to look at that. So we'll kind of hit some of the highlights as we go through it. There's a couple really important things out of chapter 1 that you definitely need to know as we kind of go on to the other chapters. But a lot of it is sort of like, what is chemistry and some math review and how to use a calculator, which is really good as well, in case you need to do that. So let's talk a little about chemistry, right? Chemistry is really the study of matter and how matter is transformed from one form to the next, how matter interacts with one another. Um, so when we talk about chemistry, a lot of times we look at chemical reactions, how things react. We also look at just really how things changes in terms of phases. We have chemistry really in all aspects of our life, even though we may not think about it too much. There's chemistry in food, right? There's food science and stuff like that. There's chemistry in like cosmetics, shampoos, those type of things. Obviously, vaccines and health care and stuff like that. So chemistry does sort of interact in a lot of areas of our lives, and we do study it a lot. And when we talk about chemistry, a lot of times we talk about composition, what are things made of? We talk about structure, how things are put together. We have a whole chapter on bonding and how things come together. Properties, characteristics, how they change. There are things, physical properties, chemical properties, and reactions as well. Again, how things react, why things maybe don't react, why certain things are involved in reactions. Now, one of the important things about chemistry is matter, and matter basically is everything that makes up the world. It has basically mass and occupies space, is pretty much everything. When we talk about matter in chemistry, there's really sort of three states of matter that we oftentimes deal with. Um, I'll do it here. So we do have, for example, the solid state of matter. And in the solid state of matter, typically what is going on is we have a lot of atoms or molecules. They are usually, in most cases, in terms of the solid state, they are packed in there pretty tight to one another. The reason they're packed in there pretty tight to one another is they oftentimes will not have a lot of energy. So what happens is they kind of all slow down, they lose a lot of energy, and they all just kind of pile in on each other. We also have the liquid state of matter. And in the liquid state of matter, we still have everybody relatively close to one another. But one of the major differences between sort of solid and liquid is in the liquid state, they actually have a lot more energy. And because they have a lot more energy, they're actually moving around a lot more and they're able to actually pass each other. This is why when we have a liquid, right, it pours, right? Like water, right? It pours and it can flow. And that's because there's a lot more energy and things are moving around each other, as opposed to something that is a solid like ice, right? And you pour it out, it just all comes out together, right? Because they're all packed together, nothing's moving past each other. And then we also have the gas state of matter. And in the gas state of matter, that is when everybody has basically completely broken apart from one another and they're flying around. They have a lot of energy at that point because they are constantly moving around. By the way, it takes a lot of energy for them to get away from each other to do that. As they are flying around, as we'll talk about when we get to the gas chapter, as they bang into like the walls of the container, that's what we associate pressure with when we talk about gases, right? And the more collisions, for example, the more times they hit things, the greater the pressure that you have. And that, again, is a result of them just constantly sort of flying around with a lot of energy. So a lot of what we look at in chemistry has to do with matter, how it changes, for example, from one state of matter to another. As it transitions from one state of matter to another, there are certain transitions that we talk about. For example, if I go from solid to liquid, that is the process of melting, right? So if you think of like an ice cube, it will just start to melt, right? If you take it out of the freezer. So that is the process of melting. If you feel bad about your liquid water now, you could take it back from liquid to solid through a process known as freezing, right? You would take your liquid water, put it into the freezer, how you make ice cubes, right? And that is the process of freezing. As we go from liquid to gas, that is the process of evaporation or vaporization. And there is a process if we go from gas back to liquid, that is the process of condensation, right? Like when you take a shower and your mirror gets all wet, right? That's all that condensation that's occurring as your steam from your shower hits the cold surface of the mirror and then actually goes back to the liquid phase and becomes water. There's a process where you could go directly from the solid, skipping the liquid phase, going directly into the gas phase, and that is what is known as sublimation. Common example that probably most people may be familiar with is dry ice. Dry ice is really not water, it's actually carbon dioxide. Dry ice, if you ever used it, you shouldn't touch it because it's really, really cold. You're going to burn yourself. They use it to burn off things on people. But it will go from solid directly to gas with no liquid cleanup, right? Halloween, like people like to bring out the dry ice for the steam and stuff like that that comes out as you do it. We also could go from gas back to solid. Once again here, skipping the liquid process. And that is what is known as deposition. Like you're going to deposit something on something else. Maybe you're old enough to remember CDs, DVDs, or maybe you've seen it online. I don't know. But they're very shiny if you ever have seen a CD or DVD. And that's how they get it really shiny. They actually deposit metals on top of it that makes it really, really shiny. So these are the different sort of transitions that occur as we change states. And one of the major components of what we study in chemistry is energy. And energy plays a really big role of what's happening as we do this. For example, as we go from solid to liquid to gas, in terms of energy, do I need to put energy in to do that? Or do I need to remove energy as I go from solid to liquid to gas? What do you think? Energy has to go in. So if you just think about the ice cube, right? It starts to melt. It starts to melt because it picks up the heat and energy from the surrounding air. Heat transfers from hot to cold, right? So when you take an ice cube out of the freezer, the surrounding air, room temperature air, is actually hotter than the ice, right? So all the energy from the air goes into the ice cube, and that's why it just starts to melt, right? When you take it out without you having to do too much to it. If you go cook some pasta, right, you get some water, put it on the pot there, you put a fire underneath there, right, it starts to boil, right? And when it starts to boil, what you see coming off is steam, and that's the transition of liquid water to gas, basically steam, and you're providing energy into that water, again, from the fire that's underneath it as you heat it up. And those processes all basically have energy being absorbed. And one of the key things in terms of energy and chemistry is whenever we have a process where energy is absorbed, that is what is known as an endothermic process. So when somebody says this process is endothermic, that means somebody is absorbing or gaining energy in that process. Obviously, the opposite is true here. If we're starting at the gas and then going to liquid and then going to solid, in these processes here, we actually need to remove heat and energy. So if you think about gases, right, they're flying around really fast. When you remove energy from the gases, they no longer are flying around really fast, which means when they come in contact with each other, they kind of stick together because they don't have enough energy to kind of break away from each other, and they kind of drop into the liquid phase. If you continue to take energy out when you're doing that, they're going to go from the liquid phase and continue to kind of lock into each other into the solid phase as they continue to lose energy. So as we go from gas to liquid to solid, we are doing all processes where energy is released. And when we talk about in chemistry, when energy is released, that is what is known as an exothermic process. So anytime somebody says exothermic, that means there's a process where energy is being given off. That, by the way, is, as I mentioned earlier, how you make ice cubes, because when you take liquid water and you put it into your freezer, the liquid water now is hotter than the freezer temperature. So heat transferring from the hotter object, which is your liquid water, is going to lose all that energy to the surrounding freezer air. The result of that is your liquid water now will come together and make ice cubes in that case, as it releases the energy into the freezer. So that's a really important thing. And especially we have a whole chapter on energy, chapter 3, but that idea again of sort of heat transferring from hot to cold. Also, when we think about energy, it is also an idea in chemistry that we think of energy as sort of this perfect sort of transfer that's going to occur. So the idea of that is conservation of energy. If something loses a certain amount of energy, somebody else has to gain that amount of energy. So this is sort of transfer. So for example, when the water goes into the freezer, all the energy that is lost by the water is all the energy that's absorbed by basically the freezer air, basically, and the surroundings in the freezer. So there's a sort of perfect transfer of energy that occurs. We oftentimes can see that transfer of energy as a result of temperature. When we look at temperature, that how the temperature of something changes. If we have water and the temperature goes from 25 degrees up to 30 degrees, the water gained energy. So for the water, it's an endothermic process. That could happen by, for example, just taking a hot piece of metal and dropping it into the water. When you do so, the hot piece of metal is going to release all that energy to the water. The result of that, what we see for the water is its temperature will start to rise. Now, if you took a piece of metal out of the freezer where it is actually colder than your room temperature water, and you put that cold metal into a cup of water that is actually warmer, what's going to happen is the water's temperature is actually going to go down because it's going to release all that energy to the colder metal. And we will actually see the temperature actually be lower than where it started for. And that would be an exothermic type process for the water, endothermic for the metal in that situation where it comes out of the freezer. So a lot of what we look at in chemistry has a lot to do with energy, how energy is being transferred from, say, one object to the next. Now, when we look at these things, for example, when we look at those two processes there of melting and freezing, do they occur at the same temperature or different temperatures? They actually occur at the same temperature. So melting and freezing actually occurs at the same temperature. So those processes there actually occur at the same temperature. And for example, for liquid water, that is 0 degrees Celsius. So 0 degrees Celsius is the normal melting point and freezing point of liquid water. When you are, for example, exactly at 0 degrees Celsius, you actually have both phases happening at the same time. You have a little bit of ice, you got a little bit of liquid water, like ice crystals, basically at exactly 0 degrees. It's really not until you get a little bit above 0 degrees that you kind of fully transition to liquid water. It's not until you get a little below 0 degrees that you actually transition to ice, for example. The same thing over here as we go from, this is usually its melting point or freezing point, as we go from evaporation and condensation occurs at the same temperature. That is the normal boiling point of a substance. For water, the normal boiling point is 100 degrees Celsius. And once again, the same thing happens at exactly 100 degrees Celsius for water. At exactly 100 degrees Celsius, you have basically both phases happening. You have liquid water happening, you got some steam happening. It's actually what, for example, happens at the surface of any liquid. There's things jumping to the liquid phase, there's things jumping out of the liquid to the gas phase, and you got things going back and forth. What determines what happens when you're, for example, at 0 degrees Celsius is energy. So for example, if you're at 0 degrees Celsius and you continuously put energy in, you're going to transition to liquid water, right? You're going to go forward from solid to liquid. As you're putting energy in there, you're going to do this process here, right? If you're at 0 degrees Celsius and you remove energy, you will actually do this process here. You will go from liquid basically back to solid as you release that energy. So what happens as we do these transitions that occur at the same temperature, say between solid and liquid or liquid to solid or liquid to gas or back and forth, it has a lot to do with energy and whether you're continuously putting energy in. If you're putting energy in and it's an endothermic situation, you will head in this direction. You'll go from melting liquid, solid to liquid to gas. If you're going exothermic, you're going to head in this direction and release that energy and go in that opposite direction. Questions on that there?